Good afternoon, everyone. Thank you for attending this session on innovation energy solution for a carbon constant world. It's a big word, basically, to think about this topic. However, we'll try in this session to maybe not solve all the world problem, all the CO2 problem, but to give you a new perspective on energy and how we're going to overcome or maybe overcome the CO2 problem. In 1997, the energy consumption of the world was about 8,500 million ton oil equivalent. In 2015, it is 13,000 ton oil equivalent. It is about increasing of 60%. However, the population of the world did not grow as such. And since then, we are doing a lot of things to reduce CO2 emission. The energy consumption based on CO2 or based on fossil energy is equal to 85% of all energy consumed in the world. So it is not very small portion. Every year we add about 34 million ton CO2 to the atmosphere. And I'm asking myself, should we be optimistic or pessimistic? We're doing, and we see since a lot of PVs project and energy reduction project and energy efficiency projects all over the world, but still we are there. We are on 85% of, let's say, CO2 energy. And when I'm talking about the rest 15%, it consists of all kinds of non-CO2, including nuclear and hydro. So let's think about it. My name is Bet Hazavdi, and I work for the Ministry of Energy, Water, and Infrastructure in the State of Israel. I do that work for the last 30 years, and I'm struggling in reducing energy in my country. I was involved in writing the National Energy Efficiency Plan, and basically I would not say that we succeeded, but the energy consumption in Israel per capita went down a little. It was 3.1 ton oil equivalent, and it is now 2.8. It is nice, but our region, I live in the Middle East, and our region sometimes it's hot, sometimes it's cold, and we depend on air conditioners. So when air conditioners operate very much, we lose lots of energy. But however, whatever, it is still, we are under the expected energy consumption, and I'm happy with that. With us, 4 speakers that will contribute from their experience in the term of how they handle energy and reducing CO2 emission, each one in his sector. The first one, Mr. Habfast, please introduce yourself in 1.5 sentence and tell us.
Good afternoon, everybody. Yes, Claus Habfast. I'm elected official of Grenoble, deputy mayor, since 2.5 years after a career in science and engineering, and I'm looking after universities, research, and large infrastructure facilities in Grenoble, a town 100 kilometers from Lyons in the French Alps.
Go ahead.
Can we play a presentation then, please? Yes, I would like to talk about what we do in Grenoble to reduce our carbon footprint. But as an elected official, if you go to the next slide, you will see that there is a problem in making things happen. I'm not reporting to a CEO. I'm reporting to 450,000 citizens. And making carbon footprint reduction happening means also that citizens have to change. And when you get if you forward please to the next animation, you will get the problem that citizens will not want to happen it in their backyard. The American citizens have just, thank you, that's nice, it's very useful. The citizens of America have just elected somebody who will not make carbon reduction happening in that country's backyard. And of course, we would like not this to happen in Grenoble. We would like that citizens embrace reducing carbon emissions. And we believe that the district is a good scale, not a big city, but the district is a good scale to experiment and to start. So I would like to talk about areas where we can make this happen. First, just a few facts. I don't want to lose much time on this about Grenoble. It's a university town, 60,000 students. The Metropolis is having 450,000 inhabitants. It's a very international town. It's a very innovative town. We have been number 2 in the iCapital Prize of the European Commission 3 years ago, and a large Anglophone community. But Grenoble is also a town with lots of poor people. It's a town with districts where youth unemployment hits 60%. It's a town which symbolizes also the fact that we are getting a slimmer and slimmer middle class in many industrialized countries. And we are aware of the dangers of this. We do have, since 2005, a plan to reduce our carbon footprint, to reduce energy consumption, greenhouse gases, but also to reduce pollution, because we are a very dense urban area. And as you can see, we do have results. Our carbon footprint is getting smaller. It's also helped by some specifics of the French energy production. I'll come to that later. And we have objectives which are even more ambitious for 2020 and 2030. So I would like to talk about reducing commuter car use, because cars still use carbon in France. Petrol, that means they produce CO2, about district level smart grids in order to get to grips with renewable energy production, and about empowerment and how to use ICT and IoT in citizen empowerment. And all this to reduce CO2 emissions. Commuter car use. So Grenoble is of course having, like all French big cities, a very powerful public transport system. And like all big French cities, we have large traffic jams in the morning and in the evening. So what do we do in order to get people out of their car where they are traveling alone to work and back home? First of all, we have in place now a very powerful bike rental system. And we believe that for cities like ours, renting out a bike or leasing it out to the citizen is more powerful than bike sharing. So people get a yellow bike, and you see one of those on the top, against a modest fee rented from the same company that operates the public transport. And the employers can then choose to reimburse the lease fee instead of reimbursing the part of the price for the transport pass. And that works very well. We have 6,000 bikes out, and people who normally, when it breaks or when it doesn't work anymore, it's all replaced. It's a full service. We also would like to get, that's new in France, smart highways. You won't find in France high occupancy vehicle lanes or lanes reserved for car sharing. You won't find in France on the urban motorways traffic flow control. And we have made the bold decision to tell the government that they should change the rules, and that this should become possible. And we'll get this into place, hopefully, in the frame of a rebuild of 40 kilometers of urban highway into a more pacified system of urban transportation. And finally, we work with companies to put into place action plans on the large company level, or even among the several companies, where employees get benefits of various kinds in order to move from solo car use to car sharing, bike use, or public transport. And that shows results. In one district, the Presqu'île district, we have gone down with solo car commuter use from 80% to 35% today, and we want to get that down to 20% by 2025. and these are results that can be shown and that are actually achieved by the employers, by the companies working with the employees. District level smart grid. Now in France, 80% of electricity is nuclear and the rest is hydro. There's a little bit of photovoltaic and a little bit of wind power, but it's mostly nuclear. So we believe in Grenoble, we elected politicians, that this nuclear power will go one day. That means we have more time to go to renewables, but still it has to be done. And it could be done, it could be smart to do this at the level of districts, because in large urban areas, people are living in condominiums and not in individual houses. And that means if there is local energy production by photovoltaics or others, it will not be done at the household level, but at the building or at the district level. So we will, of course, try to work to get renewable energy production up in our metropolitan area. But we would like at the district to work how to feed this intelligently into the grid, which in France is still to a large extent a top-down grid, driven by the system that there are 50 nuclear power stations and 50 million people using the electricity. But at the same time, we have to make our grid therefore intelligent. And we have to renew a large part of the installations, and we are working, for example, then of integrating also the high power and high voltage element into this smart grid, because in France at the moment it doesn't exist. And because we have our local distribution company that operates electricity distribution in Grenoble, it's not Enanet, it's a local company. We do have the possibility to make this happen in Grenoble at the local level, together with Siemens and Schneider and the university, who are having the R&D excellence in order to make a smart grid. Finally, because it's only 8 minutes that we are supposed to talk, and as a first speaker I would like to keep to this, I would like to talk about the citizen empowerment and ICT, or what does actually software and citizen relations play a role in all this. The issues are, of course, that in a densely populated area like France, with highly regulated electricity prices, energy is thought of a cheap commodity. The price of energy, in particular electricity, is a very highly political issue, and people are not really encouraged today, in particularly as concerns electricity, to reduce the consumption. On the other hand, there are households, an increasing number of households, who cannot pay for their energy consumption if you take it as an aggregate consumption. Petrol, electricity, possibly fossil fuels for heating their home if they are living further out. And we would like to use the smart metering as a first step in order to work with citizens to empower them to understand the issues of energy use in order to master the energy consumption. At the same time, we have also a project underway where we actually look at the overall energy consumption of buildings in housing projects in order to understand whether the design values meet, whether the actual performance values meet the design specifications. Because this is, funnily enough, often not the case. In the end, what is promised is not the actual performance. And we would also like, in particular around the area of smart metering, to shift the power of deciding from utilities to citizens. We in Grenoble, as elected politicians, believe that the data of your household should not be the leverage in order to get cheaper electricity. We believe that people who are rich should not have the freedom to consume as much energy as they want and keep their privacy, whereas those who are not rich have to sell the data of how they use in order to, or even have to accept restrictions in how they use energy because they cannot afford to pay the same price for energy. We believe that citizens should be empowered by understanding the issues to make the right decisions and the right choices, and they should be forced by the tariffs or tarification into this. So we will use big data not only to get a better grid, to get a more performant grid, to modelize the grid. We would also like to use big data from the smart metering in order to work with citizens so that we become responsible citizens in order to understand the issues of carbon change, and then don't think that we do things in the backyard they don't want, but that we understand that by responsible energy consumption you reduce actually the carbon footprint. So I hope I have been able to show you that we're striking the balance between complexity of reducing the carbon footprint and the leverage you have as a politicians. The district is a good scale, and we can then scale it up to the city, and that's our plan for the next decade. Thank you very much.
Thank you, Mr. Habfast. Well, are we energy efficient? For every ton of oil, primary oil or primary CO2 energy we consume, the maximum that we use, it's less than 50%. We can cut off at least 50% of the all primary energy that we use. This is something that we have to think about it. Our cars are not so efficient. Our electric power station, they work in between 33 to 55% efficiency. So we throw lots of energy away. The next speaker, Mr. Dr. Andrea Florence from Mexico, will address us the point and show us how does he overcome this or make the solution in Mexico. Thank you.
Thank you very much. First of all, thank you very much for the kind invitation to be with you today. I come from Centro Mario Molina. That's an environmental and energy think tank in Mexico. It was founded about 12 years ago by Professor Mario Molina. He's a Nobel laureate in chemistry, actually the only Mexican Nobel laureate alive. He founded the center with the idea of providing inputs, technical and scientific, for policy making and for improving the way decisions are made by all actors of society. I will talk a little bit about the general context, even if I go to very basics, and then I will dip a little bit more look deeper into Mexico's challenges and tell you a little bit about what the Mario Molina Center is doing to address some of those challenges. First, on the global context, as you may already know, last year we reached in the atmosphere 400 parts per million of carbon dioxide. That is something that the world had not experienced since the Pliocene. That's more than 3.5 million years ago. So we as humans never lived in a situation like that before. That implies that the temperature is increasing. We already observed last year also, in 2015, that we have reached 1 degree centigrade over what we had before the industrial times, industrial revolution. Last year also, it was the warmest year on record, and it is 99% or more likely that 2016 is going to break the record once again and be the warmest year in history, at least since we humans inhabit the planet. There are some reasons to be optimistic. Last year also, it was a breakthrough year, I would say. The Paris Agreement was signed, and the main objective in the agreement, they are actually meeting now in Marrakesh to put it in place already. It entered into force this year. The main objective is to not surpass 2 degrees centigrade global warming. Unfortunately, with what we have in the agreement in terms of commitments from all countries, will take us closer to 3 degrees centigrade. That is assuming that all the commitments are going to be achieved as planned. So there's still a lot of work to do. Mexico has, I will talk a little bit in more detail about Mexico. Mexico has emissions per capita of about 6 tons per year. That is more or less the global average as well. In order to reach 2 degrees centigrade warming, we would have to decrease our emissions to 2 tons per year. That is 1/3 of what we have now. And that applies for almost everybody in average in the planet. Of course, the richer the countries, the richer the groups within any country, the more energy we consume. So we have more of a challenge to achieve the targets if we are serious about limiting global warming. Mexico is also a very highly urbanized country. Almost 80% of the population now lives in cities. And these cities are the main engines of the economy. They contribute about 90% of the national GDP. By 2030, we expect that we will have 20 cities with more than 1 million inhabitants, and one city, the Mexico City metropolitan area, or megalopolis area, as we call it today, will be reaching 24 million inhabitants. We will have one mega city and 20 more very large cities of more than 1 million people. So there are many challenges related to how we produce and consume energy and how we are tending to urbanization and the way we are doing it. Of course, water is a major issue in a country like Mexico. We have major water scarcity in most of the country, and that will remain or even get deeper, graver as a problem. We also have issues of mobility. They are closely related also with energy consumption. People still, more than half of the people in Mexico live far away from public transportation, so they have to use private cars or other means to move themselves, and that increases their expenditure. Almost 25% of household income now, in average, goes to transportation in Mexico. So there's a lot to do in terms of mobility to improve the way people move and goods and services are transported. Of course, there are issues of waste generation, air quality, closely linked to the model of cities we have. And this all leads to the major challenge of energy use. About 75% of greenhouse gases emissions in Mexico derive from cities and activities taking place there. We at the center have been providing a lot of inputs and have done a lot of analysis about these issues, and we are proposing a shift in the way cities develop and a model that is more of a compact, connected, and closed city, which is totally opposed to the model we have today of dispersed, distant, and disconnected cities. In the last many years, probably 10 to 15 years, many of the social development dwellings were developed very far away from city centers, and that created even additional problems. To these ends, we developed a tool very recently, and it has been put in place by social housing providers. There are 3 government entities in charge of defining where developments are going to take place, and this tool helps to assess, in a way, the sustainability of any planned housing project, depending on the distance, for instance, to services and to jobs. With this, we have helped definitely to redensify cities. There's a lot of idle land in cities, empty lots in the center of the city. Of course, there are many reasons why people don't want to move there, but if there's proper security, for instance, and transportation systems and services, probably we can help to redensify those areas and use the constructed infrastructure we have there. We are also developing at the center an urban information system. There's always the complaint in a country like Mexico, and I think it is the same case in many developing countries, that there's not enough data to sustain policy making. So we are trying to help on that regard as well. And we are developing not only an information system, as I said, but also a set of indicators to assess cities, to compare cities one against the others, and also to assess progress in time in terms of some of the major sustainability and competitivity issues that cities want to be assessed by. We are also working with specific cities on concrete projects. For instance, in Mexico, we are now developing a concept that is called eco zones. It's very much similar to the German Umweltzonen. And there are 2 cities already, medium-sized cities, more than 1 million inhabitants, Toluca and Cuernavaca, close to Mexico City. They are already developing their eco zones, which are going to prioritize pedestrian movement, to prohibit cargo movement, for instance, at certain times of day, things like that that will help improve the environment, to help abate, of course, emissions, and also to improve air quality and reduce exposure of population to some pollutants. In summary, these are some of the advances. I just wanted to mention a few of them, and I'm open to any question. Thank you very much.
It is often, we see that there are increasing in energy demand or energy consumption, or decreasing in energy consumption. And sometimes grids are very difficult to handle this situation. Our next speaker, Mr. Bart Sloep, will show us a way how they solve kind of this problem.
Thank you very much, Eddie. First of all, my name is Bart Sloep. I'm actually working with MC Automobile Europe. It's a Mitsubishi Corporation company in Europe, specialized in automotive. But I'm representing today Mitsubishi Motor Corporation, which is actually the car manufacturer. And as we all know, car manufacturers produce cars which bring CO2 onto this earth. But we all have strong targets to reduce this as much as possible. And now we even are looking how can we use the car most efficiently to keep the lower CO2, or maybe final even the zero-2 emission from the vehicle side. A little bit back into history. Mitsubishi Motors has been producing electric vehicle cars from 50 years ago. It started all with developments, but finally from 2008 we were able to bring a mass product onto the market. At that stage, the mass production was not really adopted yet in the current world. But what we noticed from 2008 up to now, the market is growing. And the EV vehicles and even the plug-in hybrid vehicles are there to stay. At this moment, we have a share of approximately 1% in the plug-in hybrid vehicle sales in Europe, which brings that there's more than 130,000 vehicles delivered. If we look then to a smart city, what does a smart city need? We have seen the example from my colleague here they are all looking to lower the CO2 emission. How can we do that? Transport is one of the important items there, but they have to cope with increased electricity demand by introduction of electric vehicles. The increase of renewable energy usage, lower the CO2 emission, improve the air quality, and then there's still the traffic congestion and the energy grid. With the above things mentioned, Mitsubishi Corporation is working towards a vehicle to X world. And what does vehicle to X mean? First of all, currently we have two vehicles on the market which have a reasonable large battery capacity, 12 up to 16 kilowatt hours. Those vehicles during the day, or actually during their lifetime, are being parked for 95%. So they are not driven. Actually, the batteries are not used. They are only used to charge. Mitsubishi has now considered we should use those batteries in order to support the smart cities, in order to support the energy management, in order to support the grid. So both vehicles are able to discharge the batteries. If we then look at what is currently happening in the energy management, the Internet of Things is becoming bigger and bigger, and all items start to communicate with each other. And also the vehicles start to communicate. Then if things communicate two-way between each other, as well as the energy flow can be a two-way direction, we can create a smart grid, including batteries from electric vehicles. This is a kind of overall picture. It's a little bit small, I guess, to read. We have a stand here on the exhibition, I'm most willing to explain more in detail about that, which is a kind of vision from Mitsubishi Motor Corporation. To go a bit more in detail, it starts all with a vehicle to home. It's effective use of renewable energy. It's possible of peak shaving if you have own energy production, and you can manage your demand and response. Well, if we increase that with multiple vehicles and a bigger building or even a condominium, we get a vehicle to building or a vehicle to business. Finally, Mitsubishi said, okay, it's actually a vehicle to community, vehicle to the district, as mentioned before. If we manage the energy in the district or in a city, it's a vehicle to the community. And if we all aggregate those vehicles and we are able to maximize the flexibility of the battery inside the car, we can speak about vehicle to grid. Vehicle to grid is linking from the home, as I mentioned before, and currently Mitsubishi has started to implement this solution in several projects. One of the projects recently started in the light of Amsterdam Smart City. We have selected several enthusiastic households. They are performing the first tests with reasonable proper results. We selected houses with PV systems, but it can also be houses with heat pumps or other energy systems. It's a project based on support from the Dutch government, but the aim is to scale up quickly and make it a commercial viable solution. Then, if we scale up in a plural vehicle-to-home situation, we come to the vehicle-to-building. It's related to the building energy management. More and more new buildings are built with zero or even an energy production. Vehicles and even used batteries can support those systems. And if in the end we can aggregate those buildings again, they will contribute towards the society. An example of vehicle-to-building Mitsubishi has been building in their own offices, and we have seen several bigger customers with many EVs. They show an interest to start up these vehicle-to-building systems. Finally, vehicle to community. Why do we say vehicle to community? Electric vehicle is not only using the battery, it's also using the vehicle for other things within the community to lower the CO2 emissions. Examples of those could be seen as using them for security, for car sharing, for tourism, and actually for energy management. There's several projects or actually initiatives from cities or regions where electric vehicles are now being implemented. And in the V2X world, the electric vehicle becomes part of the society and is there not only for commuting, but mainly to maintain the ecosystem. As I mentioned before, what is vehicle to grid? If we can aggregate all those vehicle to X solutions, we can connect them to the grid, and then we can do frequency containment reserves, which is currently done by traditional power plants, or even it's done by nuclear power plants. Actually, when we take all the batteries of the vehicles together, they can act much better and much quicker. So the energy network will be much more stable. And it's a big thing coming up with the introduction of all the renewable energies, which are much more volatile than the existing power plants. How does it work? There's an aggregator, which can be on a regional level, on a national level. It aggregates the vehicles connected one way to the house or to the building, or actually to the community, so in public space. And with this aggregator, you can offer the flexibility on the energy market. And you can do frequency containment reserve, but on a local level, you can support grid congestion or divert investments into the energy network. All of this using the batteries which are already existing on electric vehicles and which are already there to reduce the CO2, or which are already there to lower the emission of transport. Mitsubishi is continuing this search for solutions with electric vehicles, and they will introduce in the coming period a longer range electric vehicle with a larger battery, which gives even more opportunities, and a longer range plug-in hybrid vehicle. You can imagine if we increase the battery size and if we increase the speed of charging and discharging, we can cover almost the energy market with the number of electric vehicles that will be introduced in the world in the future. Thank you very much for your attention.
So, Mr. Sloep, I see you are very optimistic.
I'm very optimistic. Yes.
Thank you. Our next speaker is Mr. Tim Pryce. He will address the Carbon Trust, and I hope we all realize what does it mean, awareness and doing to overcome our CO2 problem.
Thank you, Eddie, and thank you very much for inviting me here to address this very high-profile conference. I'm delighted to be here. I'm sure the fact the representative from the UK gets to speak last has absolutely nothing at all to do with Brexit, but I'm nevertheless delighted to be here. My name is Tim Pryce, and I head up the Carbon Trust work with public sector and with cities. And I'm going to talk a little bit about a couple of features of the work we've done with cities in fast-growing developing countries, places where city population, city economies are growing very rapidly. I'm going to particularly talk about the challenge of setting climate change mitigation targets in a scenario where a city is growing very rapidly, and also a couple of thoughts about the challenge of financing projects to meet those climate mitigation targets. A very, very quick introduction to the Carbon Trust. We were set up by the UK government about 15 years ago, and we were set up with the explicit purpose to accelerate the move to a low-carbon economy. We were set up basically to help transition the UK economy towards a low-carbon model. We started off doing a lot of work in the UK. We now work around the world, and we work with cities, businesses, governments in a wide range of different ways, but of most interest today is our work with cities. We work primarily with cities in the UK, in China, in Chile, and in Southeast Asia, and indeed in Mexico. Andres knows some of my colleagues in our Mexico office. We've done a lot of work. We've worked with over 400 municipalities in some way, shape, or form to help them to reduce their energy emissions and to take steps on the path to reducing the extent of climate change. So I'm going to very briefly, over the next few minutes, talk about the example of the work we're doing in Kuala Lumpur, Greater KL. It's the capital of Malaysia, as I'm sure most of you know, and it's the fastest growing city at the moment in Southeast Asia. So the graph on your left there gives you some idea of just how rapidly the population of Kuala Lumpur is growing, and the infrastructure and the buildings are growing in tandem with that. New roads are going in all the time, new buildings are going up all the time. The mass transit system you see a map of on the right is very rapidly expanding as well. So there's a significant challenge for us in working with KL in getting the trajectory of their emissions down towards that kind of 2 tons per capita that Andres was talking about earlier. It's almost, we need to be at pretty much net zero emissions by 2050 in order to restrain climate change to the extent the scientists tell us is necessary. So what did we do when we were working with KL? This is an example of one of the municipalities we worked with, which is MBPJ, Petaling Jaya, a population of about 700,000 people. Currently, their territorial carbon inventory, their territorial carbon footprint, which we worked with them to produce, is about 3.5 million tons of carbon in 2014. And we agreed with them, they wanted to set a reduction target of about 30% of that by 2030. So they want their emissions to be more like 2.5 million tons of carbon by 2030. So you might think initially, well, we need to identify about 1 million tons of carbon savings to achieve that figure. But unfortunately, given the very rapid pace of growth of the city, the challenge is significantly greater than that. So we worked with Petaling Jaya to generate a business as usual emissions trajectory. What is likely to happen in the absence of specific projects to reduce carbon emissions and tackle climate change in that municipality? And we worked out that obviously there's an element of intelligent guesswork involved here, but we worked out that emissions would roughly double by 2030. So instead of being 3.5 million tons, there'd be 7 million tons. And that's taking into account some of the business as usual improvements in energy efficiency per unit GDP that tend to happen in most economies as they develop. So that challenge, that carbon emissions reduction challenge for Petaling Jaya and indeed for Kuala Lumpur as a whole is really quite an acute one to reduce emissions at the rate that the science tells us is necessary to keep within 2 degrees. It's a really quite stretching challenge. I haven't got time to talk about everything we did here, but we, in working with KL, with Petaling Jaya, we focused on 2 principal areas where most of the emissions across that city's territory come from. This is true of not all cities, but most cities, buildings and transport. And we looked at a range of projects, working with the city government to work out what would be practically achievable between now and 2030 to drive down emissions across buildings and transport across Petaling Jaya. So looking at buildings, we focused on industrial and commercial, which is a substantial part of the city's footprint, energy use from industrial and commercial applications. We looked at new developments, and we looked at retrofitting renewable energies and energy efficiency measures into existing buildings as well. And we did a similar kind of top-down approach looking at the city's transport emissions. Petaling Jaya, most of the transport infrastructure at the moment is road-based. Most of it is based around people driving. There isn't a whole load of other infrastructure. So we looked at primarily how can we decarbonize the road traffic infrastructure, and how can we encourage modal shifting away from cars towards walking and cycling, and what kind of policies in terms of tax incentives can the municipal government put in place to encourage their population to shift to these lower carbon technologies. And through these measures, through looking at buildings and transport, we've identified savings of around about half of that 4.5 million tonnes that I said we needed to identify to achieve that 30% target. So that would be, if you don't factor in that business as usual growth in emissions, that's more than enough for the city to meet their target. But because they're growing so rapidly, there is more work to do, and they need more help, more support, and more training to get to the kind of ambitious targets that they and the science tells us that we need to meet. And that brings me on to the sort of final couple of slides I want to finish on, which is what is the global challenge in terms of financing climate change mitigation, and what does it mean for cities, and particularly for fast-growing developing cities like Kuala Lumpur, Petaling Jaya, that municipality within Kuala Lumpur. And this slide, taken from the New Climate Economy in the UK, is an estimate, a high-level estimate, but it roughly corresponds with estimates from people like the IEN and the UN of the kind of infrastructure finance needed across the world between now and 2030. So what kind of new infrastructure finance do we need to 2030 globally? Under the base case, business as usual, it's around about 89 trillion US dollars at 2010 prices. And you can see that this analysis then says, well, what do we need to do to get to a low carbon scenario? We need to spend an additional 9 trillion on energy efficiency. We need to spend an additional 5 trillion, there or thereabouts, on renewable energy. But it's also saying that we need to spend less money in certain areas. We need to spend 6 trillion less on developing new fossil fuel infrastructure. We need to spend 3 trillion less on urban sprawl and road-based transport. And those points are almost as important as finding money to finance that low-carbon infrastructure is diverting money away from high-carbon infrastructure, because there is no way we will meet the Paris commitments to climate change. Just come from COP22 in Marrakesh. There's no way we will meet these commitments without diverting money away as well as diverting money towards. So the final slide I have, what does this mean in terms of the city climate finance challenge and meeting these incredibly ambitious carbon reduction targets in these cities that are growing so very rapidly in countries like Mexico and Malaysia? Well, the first point is that at least 70% of the infrastructure finance we need to spend between now and 2030 is going to need to be spent in cities. So the global climate finance challenge is primarily, above all else, a city climate finance challenge. The second point I would say is that all cities, and particularly developing cities, need more help and support to generate projects that are of interest to investors and are financeable, and to raise and generate their own finance. So they need support to be able to borrow. They need support to be able to generate credit ratings so they can go to investors as a good credit risk and borrow to finance these kinds of projects. And they need training. We're doing some work at the moment with the World Bank on a qualification for city climate planners to help train staff within municipalities up on how to generate and finance these kinds of projects. We need better mechanisms to verify the impact of low carbon finance. It's very easy to label finance as low carbon. It's rather harder to measure the real and verifiable impact of that investment in terms of how much carbon is being saved per dollar spent. So we need, and a lot of work again is being done under the UNFCCC process, the conferences like COP22 in terms of how do we measure in an internationally comparable way the impact in terms of carbon savings of the money that is being spent on tackling climate change. And then the final point, and I think this is worth emphasizing again, I think that new climate economy analysis is absolutely spot on. We don't just need to divert investment towards low carbon infrastructure, we need to divert investment away from high carbon infrastructure as well to meet the kind of targets that we need to meet. So yes, we need to be investing in, on the left there, mass rapid transit, in high density transit oriented development, in renewable energy and in energy efficiency. All these things are crucial, but we also need to be investing less at the urban scale in roads, in urban sprawl, in fossil fuel infrastructure, and in high carbon buildings, buildings that use a lot of energy and take a lot of energy to build. So that's a final thought I'd like to leave you with, and thank you very much for listening to me today. Thank you.
Well, I see we still have some time for questions. I'll be very happy to receive any. There is a microphone here for question from. Okay. Two questions. So we'll be able to we will be able to probably answer both of them. The question is, what are the main problems cities encounter when leading the transition to a new low-carbon energy scenarios?
Problems, well, I also already spoke about that you should not do any substantial change against the citizen, but with the citizen. And that's taking time, and it's taking lots of efforts. But what Tim said, access to capital, is really the second biggest problem, because in many cases, you have to invest, and the rules of how public authorities can invest are different to that of businesses. And our Lord Mayor, Erik Pjoll, has called for a new Green Deal. He said we should separate investments that go into energy efficiency, into reducing carbon footprint, and because they also will reduce our cost of operations. We should look at them differently than at other investments that don't produce these benefits. And we should also rate them differently when we look at credit risk and so forth. So I believe that indeed citizen involvement and make citizens embrace carbon reduction is the biggest challenge, but funding then as a public authority what you would like to do with your citizens is the second biggest challenge.
Anyone else want to refer to this question, please?
I think another point I'd make in addition to the ones I've already made is leadership. I think it's really important that the city mayor and senior staff, political leaders within the city understand the threat of climate change, understand the opportunities presented by moving towards a low-carbon economy, are able to communicate that to their staff. So I think that is a very important aspect as well.
Well, I will add to what your remark at the moment. When I'm asked, usually in cities in Israel, mayors and deputies, what they should do in order to make their cities smart, I say first, you need to want to be smart. And not just to say I want to be smart or to install LED light and you think that you're already smart. Being smart, it's very comprehensive. We need a holistic approach that will solve not only technological problem, but also a social problem and health and other things. Let's not forget that the city is for the people and not the people for the city. So with this remark, I would like to go to the other question. The other question, are there major differences in energy solution applied in developed and developing countries?
I guess I could speak for developing countries in this case. Well, I see technological solutions are the same, probably. I mean, but the availability of resources varies a lot. I mean, we don't have all the capacity, all the resources to implement the technological solutions that are available. So probably we would have to be more thorough in the analysis and try to probably to try to maximize the resources that we have in any case. I mean, that's probably the same case anywhere you are. You have limited resources and you have to optimize how you use them. But it is especially the case, I think, when you have little to do and the challenges are major. I suppose you also have to use more your ingenuity, and that's something many developing countries are very good at. Many of the solutions are not technological. They have to do more with changes in how you use resources, in how you produce, and you have to be more imaginative probably in face of having limited availability of resources and technology.
Thank you.
I think that's very true, and I think Andres probably knows more than I do living in Mexico, but I think I'd add just the fact that so many developing countries are building their infrastructure now as we speak. They have an opportunity, if they build that infrastructure right, to almost leapfrog many developed countries onto a low carbon trajectory. And yes, that's very hard, and yes, the resources are very hard to find, but if the right low carbon infrastructure is put in now, those countries could well be in a better position in the not too distant future in terms of low carbon technologies and low carbon infrastructure, things like new buildings, things like mass rapid transit.
Thank you very much. Anyone else? Please.
One point, not so much about developing countries, but developed countries. Of course, they all have in common, developed countries, that they currently have a low growth economy, and this is probably going to stay for a while. But the energy, the world of energy, particularly electric energy production and distribution, is so different from country to country that I don't think that apart from mobility, you can develop an international scenario of action. I believe that and I've been living in various countries, it's very different between Germany or France or the Netherlands or the UK. When it comes to the carbon footprint in the world of electric energy, which is of course only part, you need national scenarios. When it comes to mobility or maybe also to housing, you can work on the international level, and there you have to get the balance right, otherwise it will not work.
Yeah, my only comment, what I can add is in developing cities or countries is, as maybe Tim mentioned, they have a clean sheet. They have a clean sheet to start with, and that's a much better way to start. And they are developing countries or areas, so there are being done investments there. So we need to carefully consider how do we invest.
Thank you very much. Ladies and gentlemen, before we sign off this impressive session, I wish to express my thanks and gratitude to the organizers of the FIRA Barcelona Smart Cities Conference. I wish to thank the city of Barcelona for hosting us, very nice host. And of course, I'd like to say a few words. I might read them. 85% of the energy are consumed in cities. Cities cannot just send the problem to their neighbors. They have to solve those problems. Cities has the ability to bring or to show a good solution in increasing efficiency. For instance, just think about local production and consuming of electricity, and using a cogeneration to increase efficiency. This is one of the ways. Emerging technologies that I'm exposed to gives me the hope to believe that one day in the future, I cannot say if it's tomorrow or day after tomorrow, in one, maybe 10 years or 20 years, we will find solution and we will use energy with less CO2 or maybe zero CO2. Thank you very much for this, for attending our session. and this session is closed. Thank you.